Now we're going to make a statement that should seem pretty obvious in the context of this depth and rate of depth change situation, but which, if you go to the heart of the statement, is really one of the cornerstones of our Western scientific civilization. Okay, the statement is that if we start with a rate function y prime, a linear rate function, or any rate function, if we start with a rate function and integrate to find the depth function, and then we differentiate the depth function, we end up with the rate function once more. That statement is really the essence of the fundamental theorem of calculus. It might seem obvious, but later on it's going to take a great deal of proof. However, we want to remember this term, the fundamental theorem of calculus, and the fact that what it states is really if we integrate a function and then differentiate the result, we get the same function we started with. We could also say that if we start with a function and differentiate it and then integrate it, we end up with almost the same function we started with. However, remember that when we integrate, we can't specify this one parameter c. Now c is a constant number, so this means that if we differentiate a depth function and then integrate the rate function, we might end up with a different constant number c, which means that all our depths might be changed by some constant amount. That won't make any difference in calculating the depth change between two clock times, but it does give us a slightly different depth function. And the graph of that depth function is going to look just like the graph of the original depth function, except that it might be raised higher or lower than that graph. We will work through the details of that later.